Welcome to installment 10 of writing a 6502 assembler in assembly language. And as I said last time, I was going to look over the code offline or off screen and just see if there's some things I want to change. And it turns out there are some things I want to change. So I will do that first. I don't think it will take too much time, so I might well be able to move on to something else afterwards. First off, I will show you a few very small changes I made already when I was looking over at the code off screen. Just some very simple stuff. So, for example, right here, this was a comparison to 8, but 8 is backspace, not tab, so that had to be corrected. And then there's also the place where I increment the count of lines. This one said BEQ, branch if equal. That's actually wrong. I want to branch if lines is after being incremented is not equal to 0, then I want to branch down here. If it is equal to 0, I want to do this one. And then the one last very small change I made, I'll search for it. And that was right down here in the get C routine. Right here where we had EOF and then we checked to see, but did we actually read any bytes before we get into file? If we did read some bytes before into file, we go down here. Otherwise, we're just we're decrementing Y to be FF, so that we're going to return FF and Y, which will indicate we got into file. Here there was a CLC opcode like this, which was a leftover from the idea that this get C subroutine could return errors or not. And this CLC was indicating there is no error. But we changed that. The get C subroutine now cannot possibly return an error. It either returns into file or it returns a character or it exits the program. So if there's an actual error reading the file because the disk can't be read or something like that, then that's the end of the program. It's a fatal error. All right. So now the changes that I want to make now, the very first one is related to scanning. And that is, if we look at the ASCII, when I'm scanning here, I'm checking for all sorts of stuff in different places. But if we look at the ASCII character set, here it is, we can see that what we can do is actually go through the whole thing one time. And what we'll say is like, okay, if it's greater than a lowercase c, then these are the only possibilities, of which this right here, 7c, and this one here, 7e, are possible single character tokens. So what we'll do is if it's greater than z, we'll just go down to look at single character tokens, and that's it, we're done. Okay, if it's now that we know it's not greater than lowercase c, if it's greater than or equal to lowercase a, it's a lowercase letter at the beginning of a name. And then if it's less than lowercase a but greater than uppercase z, then it could be one of these things. It could be a left bracket, a backslash, a right bracket, a caret, or whatever you want to call it, a little pointy up thing, an underscore, or a backwards single quote. Again, the only possibilities here is maybe, well, if it's underscore, it begins a character, but we can check for that first. If it begins with underscore, it could be a name, but we'll check for that first. Otherwise, we'll go ahead and check to see, again, if it's a single character token. Now, if it's less than or equal to uppercase C and greater than or equal to uppercase A, it's a name. If it is less than uppercase A but greater than a 9, digit 9, then it could be a single character token or a two character token, whatever. We can jump down directly to that place. And then if it's less than or equal to 9 and greater than or equal to 0, it's a decimal number. And then if it's less than 0, then we have a range of possibilities. It could be a hexadecimal number starting with a $sign. It could be a quote, a character literal starting with a single quote. It could be a string starting with double quotes. So then we'll check more stuff. But basically, the way the code works now, it's kind of checking things in a random haphazard order, which means that it's just giving away efficiency. And it's true that I'm not really thinking that much about efficiency when writing the program. I want it to work. That's the most important thing. But there's really no reason to just look at these things randomly. We can go through the ASCII character set in a very systematic way and check to make sure, that to see what possibilities we have. And that way we're not rechecking over and over again the same thing, basically. So here we are. Here's where we get a character. I think the first thing I'm going to do is just, since I want to check for white space first. I mean, it's not absolutely necessary. In fact, it might be more efficient not to check for white space first, but it's, from my point of view, useful because we can get that out of the way first, and then we don't have to worry. We don't have to ever think down here there might be a white space or something like that. It's just, logically speaking, to me, it's easy to do it this way. So we're going to look for a space. If it's a space, we'll go back up to scan 0, which gets another character. Then what I'm going to do is I'm going to say that if it's greater than equal to a space, well, we know it's not equal to because that would have happened here. So at this point, this means if it's greater than a space, then we're going to just go straight down here to this place here, because this is all control characters, new lines, and stuff like that. We'll just go straight down here to scan 3. Okay, and we'll call this means it's not a control character. Well, at least not a control character apart from the delete character. Okay, and now at this point, we know that it's a control character of some sort. Something in this space right here, in this column. And we can go ahead and check. Tab is okay. We're allowed to have tabs, and that goes back up here, right? And now we have our whole carriage return new line thing where we accept a carriage return as an end of line or end of statement. We accept a new line as an end of line, end of statement, or carriage return new line. All of those are acceptable as end of statement. And that goes down here. Okay. Now what I want to do here is say if it's none of these things, like, okay, so if it's not a carriage return, then we go to scan 1 and we say, well, is it a new line then? If it's not, we go to scan 3, which is where we start checking for names. But actually, because of this here, this line here, right, we know that at this point it cannot possibly be a printable character. So we're going to go here, and let's call it scan 2A. And this is going to be a place, this is a bad character. We know it's a bad character. Okay? And let me just, so I'll call it a bad control character. All right? And honestly, I think it's easiest just to go ahead and check right up here for that delete character. Which is ASCII 127, right there. Okay, and if it's equal to delete character, we're going to go to scan 2A, which is our bad control character. Otherwise, we'll compare with the space and so on. So now we don't have to worry about any kind of bad control characters. Those, like any control character, less than, in this area, less than a space character, which is not a tab, a new line, and a carriage return, all of which we will accept, or will end up here. scan 2A. All right, and this is going to be where we throw an error saying, hey, I've got some crazy control character in the file. That shouldn't happen, right? And I think here it's actually this chur error, CHR error. Let's just go down for a minute here. Actually, what was the, there we go. That was the way we can get around page by page. Okay, bad character and input. All right, that's right here. Right, it prints this out, okay? Bad character input. Let's go back up. Right, it calls that and then jumps to error. Okay, so I'm just going to reproduce this up top, and I'm going to think about this for a minute. I think we still need this down here for another reason. Of course, we could just jump to scan 13. In fact, we probably should do that. Okay, at this point right here, oops. We should just do jump scan 13. All right, that's okay. So scan 13 is where it gives that bad character and input error message. We can't just branch all the way down there from here. That's too far. The branch can only go basically minus 128 plus 127 bytes. So we'll just use this as an intermediate place here. Or alternatively, actually, maybe it would be better to do it like this. Let me move this to scan 0C. What I'll actually do is I'll call this right here scan 0B. And what I'll do here is if it is not a 127, that is not a delete character, I'll go to scan 0B. Otherwise, I'll jump to scan 13. And scan 13 is the bad character error. Okay, so if it's a delete, just go straight to scan 0B. That's a bad character error. Okay, get rid of that. Now, if it is a space, we go to back up to get another character. If it's greater than space, it's not a control character, so we go down here to start checking for other things. Okay, if it is indeed a control character, we check for a tab. If so, it goes back up there. If it's a character turn, we go to scan 1, which is we're going to see. I'm sorry, if it's not a character turn. Sorry, if it's a character turn, if it's not a character turn, we go down here to see if it's a new line. If it is a character turn, we get another character, check for EOF. Okay. If we have EOF, it's going to basically unget the EOF, right? And consider that it saw just the character turn. If it's not an EOF, then it'll say, hey, this is the character we got after the character turn a new line. If it is, that's fine. That'll count as a line. If we got character turn and then something besides an EOF and besides the new line, it's going to unget that character wherever it was and go down and consider the character turn alone to be a new line. All right. If it was not a character turn, then we'll go in here and say, was it a new line? If it's not a new line, then it says go to scan 3, which is looking for non-control characters, but actually that has to change. So it will say if it is a new line, then we will go to scan 1A. Otherwise, we're going to jump to scan 13 Okay, so the idea is that if we get a carriage return, then it's going to be, well, eventually, no matter whether what's after it is an EOF, a new line, or some other character, we're going to end up right here, which means we're going to increment the number of lines in the source code. We're going to count the number of lines. If it's not a carriage return, we're going to see if it's a new line. If it is a new line, again, we'll go right down here. Okay. Oh, I'm sorry. Yeah, we're gonna, if it is a new line, we'll go here. Okay, and it's a line. This is the situation where we already got a carriage return, and then we get a new line. Let's be sure of this stuff. Okay. Here, carriage return. If it's not a carriage return, go to scan 1, which is see if it's a new line. Okay, if it is a new line, then go down here. Otherwise, at this point, it's a control character, but it's not a tab, it's not a carriage return, it's not a new line, so we go to bad character error. Okay, now we get a carriage return, and we get another character. If it's an EOF, we're going to go right down here, which means unget that EOF, and then jump down here to increment the number of lines because we saw a carriage return. If it's not an EOF, then we're going to say, well, is it a new line? If it is a new line, that means we get carriage return new line, which means increment the number of lines to continue. If it's not, if we get carriage return, but then something besides the EOF and besides the new line, we're going to unget whatever that thing is, and we're going to go down here. We're going to go down here to increment the number of lines because we just got a carriage return. Okay. And then if we get, this is the point where we got a carriage return followed by a new line, or just a carriage return, or we got just a new line. We're going to call that a end of statement token and return. Okay. So this is the case where we got CR, look for CRNL, looking for carriage return new line. Okay, this is the EOF. Okay. Got CR EOF. Okay. Got CR NL. This is where we got, so we have to unget whatever comes after the CR. And so this is got just a carriage return followed by something else. Okay. Didn't get CR, look for NL. That's the situation here. All right, and if we didn't get CR, if we got NL, then we get on here. Here we got end of line, either CR. Actually, I should call it LF, right, for line feed. That's what it really is. Or line feed. Just call it's the line feed character, so I'm just changing these things here. Okay. So now we have the situation that at this point, we know for absolute fact that we don't have a control character. It's a printing character. Okay, and I think checking for names is the right thing to do. We're going to look for a period or an underscore first just to make sure. And now we're going to say, okay, look, if we get something greater than a lowercase z, all right, something greater than a lowercase z means it's here, one of these things, except for not the delete. We've already taken care of that. All right, then that means it can't possibly be anything except for just a single character token. Right? That and that are single character tokens. 7C and 7E are valid single character tokens. The braces aren't anything valid, but that doesn't matter for us right now. So what we're going to do is we're going to just immediately jump all the way down to where it checks for single character tokens, which is right here. Check for single character tokens at scan 12. Okay, so instead of branching to scan 4 and checking for hexadecimal number here, at this point, we know that it couldn't possibly actually be a hexadecimal number because it's one of these things here. So we have to branch around. Again, we can't just jump to scan 12. It's too far. So we'll say if it is less than or equal to a lowercase c, then we'll go to scan 3a. Otherwise, we'll jump to scan 12. All right, and when we jump to scan 12 here, it could only possibly be a single character token. Okay, so now we see if it, at this point it's less than or equal to a lowercase c. If it's also greater than or equal to a lowercase a, then it's a name. Otherwise, we're checking against to see if it's now less than a lowercase a, but greater than an uppercase c. And that is going to be this range here. Left bracket, backslash, right bracket, caret, underscore, and back single quote. Well, for us, we've already taken care of underscore, and a caret is a single character token. The rest of the stuff is not something we care about. But anyway, the point is, the only possibility here is single character token. So again, we can just say, in fact, if it's less than or equal to capital Z, we're going to go to scan 3B. Otherwise, we would jump straight to scan 12 to look for single character token. All right. So now at this point, we have something which is less than or equal to a lowercase c, uppercase c, and greater than or equal to an uppercase a, means that we go to name, sc name. All right? And now we have to actually insert some stuff here. So at this point, we know we have something less than an uppercase a. That means it's here, this, either the @ sign or any of this stuff, but we're going to check and see if it's between uppercase 9 and, between digit 9 and uppercase A. So we can go ahead and say compare to digit 9 plus 1. Okay, if it is greater than or equal to, if it's greater than digit 9 but less than lowercase a, that means it could be colon, semicolon, less than, equal to, greater than, question mark, or @ sign. Some of these can be single character tokens, like @ sign, for example. And we're going to have to deal with later with semicolon being a comment marker. I haven't taken care of that yet. These things can be 2 character tokens or single character tokens. So we can't go to scan 12 and look exclusively for single character tokens. We have to go down and start looking for these double character tokens. And that is right down here at this point. scan 8, where we look for things that begin with less than sign, equal sign, right? Or, I'm sorry, less than sign, or greater than sign, or equal sign. So we'll have to go to scan 8. All right, so if our character is less than a lowercase a but greater than a digit 9, we will go to scan 8. And let me think, can we get there with a, yeah, it's pretty close. So we can just get there with a single jump, with a branch. Okay. So at this point, we're saying if it's less than lowercase a and greater than digit 9, it will go to scan 8. It's in this range right here, from here, here. Okay, now we will compare with a digit 0. If it's greater than digit 0, greater than or equal to digit 0, and less than or equal to digit 9, it's a decimal number. Okay, so what we'll do, here we see, here's we're checking that stuff again. Okay, so what we'll do is we'll just basically go right down here. We'll call this stuff can be deleted. And maybe we can make this a little bit nicer, but and now we're not really checking, we'll just say decimal number. You know, actually probably what we should do is just this, okay? So if it is less than, what we're saying here is that we have something which is, we're comparing to 0, and it is, what we'll do is we'll say if it's less than 0, let's go to scan 3C, which will be here. Otherwise, just do this stuff right here. JSR on get C and jump get dec. So get a decimal number. Okay. Now I did have a thing here. This can go away. I did have a thing here where I was loading y with 0. The reason for that was because we want to make sure when we unget, we call unget C, we unget both a and y. Both get returned to our peak C variable, which is a 2-byte variable. But I'm not going to do that here because I'm just looking here. I know for a fact, I can see everything here. Y has not been altered. Y has not been altered. For us to get down there, what happens, we got a character here, which of course could alter y. It's going to return y as either 0 FFF or FF. We say, okay, it's not a delete. It's greater than a space, so we'll go down here. And now we're just checking. We're not doing anything that can modify y. So y is untouched here, so we don't need to clear it to 0 before we do this unget here. Okay, so now at this point at scan 3C we have something less than a 0. So we have all of this stuff here. And that's actually important. And we have our decimal numbers there, our hexadecimal numbers there. We have our strings, we have our single quotes, and all that stuff is in that range. So we'll have to check for all that stuff. And I think, you know, we can just do this here. This is actually going to be 3D. And here we're going to say, at this point, we're going to say if it is greater than or equal to a, we'll go to SC name. In fact, if it's less than a, we're going to go to scan 3C here. Okay, and now otherwise this, this is in fact SC name here. SC name is just going to JSR ungetC to unget the letter or whatever, and then jump to get name. So this can go away now. Same thing with Y there. Okay, and then this can actually go to scan 4. That goes away. Okay, so that looks good. Let's just go over it one more time. I want to make sure. I start off by checking for period and underscore. Underscore is here. Period is up here somewhere. That's it right there, I think. Just to kind of get them out of the way as far as names go. If we get period of underscore, we go to name, which is just ungetC and jump to get name. All right, then we start going through the ASCII character set this way. All right, if it's less than or equal to a lowercase z, then we're going to keep looking. Otherwise, it could only possibly be a single character token, and we jump to SC12 to look for single character tokens. We compare against lowercase a if it's greater than or equal to lowercase a, and also this means less than or equal to lowercase c, it's a name, so we go down here. Okay. Otherwise, if it's less than lowercase a, and we check against uppercase z, okay, if it is also less than or equal to lowercase c, we're going to go down here. Otherwise, at this point, it's greater than uppercase c, but less than lowercase a, which means, again, it could only be one of these things. So it's a single character token or a bad character, one of the two. If it is less than lowercase a, but greater than digit 9, then it's in this area here. And we need to check and see if it's one of these tokens that begins with the less than sign, greater than sign, and so on. That's why we go to scan 8. Otherwise, we check it's less than or equal to digit 9. We check against digit 0. If it's also less than digit 0, that means it's in this range here. And we're going to go down here and start looking for things like hexadecimal numbers and whatnot. If it is greater than or equal to digit 0, and also less than or equal to digit 9, then we're going to unget it and call it a decimal number. Okay. So at this point, we're checking for hexadecimal numbers. We're just looking at this stuff down here. Is it a hexadecimal number? Character literal. Here we're checking for string literal. Okay. Otherwise, check for these things like tokens that begin with less than sign, tokens that begin with greater than sign, tokens that begin with equal, tokens that begin with exclamation point. Check for single character tokens. And we just look through our token table. And if we find it, then good. Otherwise, we return a bad character error. So that means, for example, if we get a left brace, it's going to be a bad character error. The same as if we got a control character of some sort, because they're both bad characters in our source file. So that all looks good. So that's the changes I want to make in the main scan routine. Okay, then at this point, we're looking for hexadecimal number. If we get a $, it's hexadecimal. We're storing some non-zero value in first flag plus 1, so getHex knows that it is indeed the first character, so that there has to be at least one hexadecimal digit, otherwise it's an error. That's why we have to do this here. Checking for a character literal, is it a single quote? Okay, just to move back to here, see the single quote is right here. It's decimal 39. If it's a single quote, go to get CHRL. Otherwise, look here. Is it a double quote? If it is, go to get STRL. Otherwise, go here. Check for tokens that begin with less than sign. Okay, is it a less than? If not, we're going to go down and look, see if it's something else. Otherwise, we get a character because we want to see if it's less than or less than equal, something like that. If we're looking to see if it's an EOF. If it's EOF, we go down here to unget the EOF. But the thing is, this is actually, I know I did this. When I did this, I was thinking, oh, better safe than sorry. But the reality is I know that this Y, whatever Y is, comes from this getC right here, and there's nothing has changed it, so we don't need this this load Y0. It's unnecessary. Get rid of it there, okay? So if it's not EOF, then is it a less than sign? If it's not less than, if it is less than, then load left shift. If it's not less than, then see if it's an equal sign. For that would be less than or equal to. If it's not, go down here. If it is less than or equal to. So if we got a less than sign and then we didn't get an EOF and we didn't get a less than, we didn't get an equals, then we're just going to put back whatever it was, put it back, and return a less than symbol. All right, so this is basically exactly the same. And exactly the same in the sense that we know for a fact we don't need this here. We don't need that. If it's greater than, if it's not, go look for something else. Otherwise, get a character. If it's EOF, unget it and return greater than. Otherwise, if we get greater than, return right shift. If we don't get greater than, do we get greater than equal to? If we do, then return greater than equal to. Otherwise, unget whatever the character is that we got and return greater than character. Okay, same thing here. Equal sign. If it's not equal, go on down and check something else. If it is, get a character. If it's an EOF, unget that thing. And just like before, we don't need this. Load Y0 because we're talking about literally from here to here and Y is not altered. Okay, if we get equals, then we're going to return, that's going to be equals, not an assignment. Otherwise, if we get equals followed by something that's not an equals, we just unget that thing and return the equal sign by itself, which just is an assignment. And same thing here, we're looking for not equals basically. Okay, if it is not symbol, if it's not an exclamation point, then go down to look for other stuff. Otherwise, get a character. If it's an EOF, again we don't need this. Get rid of that. We can unget the character and return the exclamation point. If it's exclamation point equal, return not equals. Otherwise, we unget the character and return exclamation point. And then down here, we're going to look for single character tokens by looking in our token table. If we get something which is not in a token table, it's a bad character error. Okay, and now we have the get hex routine. We've gotten a $sign. The first flag right here has been set to something non-zero after we see the $sign. Okay, so we're going to get a character. We checked first to see if it's a new line character. EOF. If it's EOF, then Y is not equal to 0. And we're going to go down here and we unget it. Okay, that's no good. Actually, the EOF case needs to return to. It needs to go to first flag. So in other words, if there is an EOF, okay, then we need to go here and see, is this the first character after the $sign? Okay, and if it's the first character after the $sign, then this will be non-zero, so it'll go to bad hex. Okay. Otherwise, if it's not the first character, then we can go ahead and unget. But I think it's very clear Y is not going to be affected, okay? So if it's not an EOF, then if it's less than a 0, again, we go down here, which means it's the end of our hexadecimal. Either it's okay, it's the end of hexadecimal because we got a hex digit, or not. That's what this right here checks. Okay. So this is, at this point, okay, we have something which is between 0 and 9. We go to decdig, which is there. Okay. And then we check to see if it's between A and G. If it is, we go to ABC dig. If it's between lowercase a and lowercase g, we go to ABC dig. Otherwise, we're going to go to first flag right here, which is when it's not a hex digit, and that's the end of our hexadecimal number. Okay. Decimal digit just subtracts the ASCII 0 from it. And it subtracts ASCII 0 minus 1 because carry is clear. You can see it's all BCC, BCC, BCC. So that means it'll subtract whatever I put here, which is ASCII 0 minus 1, but it will then also subtract another one, which means it will subtract ASCII 0. If it's an ABC digit, we're first going to change it to an uppercase right here. If it's lowercase, it'll get changed to uppercase here. And then we subtract 6. And then we go ahead and subtract the ASCII 0, which means that A will turn to 10, B will turn to 11, and so on like that. We save that for just a moment because we have to shift our token value, that is the binary number that we're building out of this hexadecimal constant, shift it left by 4. That's why there's this 4 here. Okay, so shift, decrement, and as long as we haven't done it 4 times, go back up here. And we're going to go ahead and clear this first flag right here because we have seen one hexadecimal digit, so we'll clear that so we won't have any. Next time we get a character which is not a hexadecimal digit, it won't be flagged as a bad hexadecimal number. That's the purpose of this here. We get back the value of the digit. We add it into the token value. It's a 2-byte addition, so that's why it takes all this stuff. And then we jump up to get the next character. Okay, so that looks good. GetDec is called with a valid decimal digit having already been read and ungot. Okay, so we first clear tokval. Actually, did we not do that up here? We did not. That's ugly. We need to clear tokval. Okay, that means we're going to have to change this to get hex 2. And this will be get hex 2. And we'll get hex. We just have to clear the token value. We have to start out with the value of 0, otherwise who knows what we'll get back. Okay. Just like here. Get a character, see if it's between 0 and 9. Now in this case, we know that the first one will be a character between 0 and 9 because that's what we did up and above, up here somewhere. I don't want to go back up there, but we saw that we had a digit between 0 and 9. We did unget, and then we jumped to getDec. So we don't have to worry about this, whether or not the first digit is a valid digit or not, like we did for the hexadecimal case. Okay? Basically, if it's not a decimal digit, we're going to go to getDec 9, which says ungets it and returns number. If it is a valid decimal digit, we have to multiply our token value by 10 first before we add in the value of the digit, which we do by shifting it left 1 time and remembering that 1 time shift of that value in X. Okay. And in Y. I'm not sure why we have it there. Let me just think. Okay, so shift it left 1 time. Oh, yeah. We shift it left 1 time. This should be +1. That's the mistake there. Okay, shift it 1 time, and remember that. This is multiplied times 2. Then we shift it 2 more times, which multiplies. In total now, tokval has been multiplied by 8. Then we add in the multiplied by 2 version to the multiplied by 8 version. So that means It will be multiplied by 10. Okay, then we get back the value of the digit that we pushed right here, and add that into the token value, a 2-byte addition. And then we go back up to get dex 0 to get the next character right there. Okay, found a little mistake, but otherwise looks good. Okay, get escape characters. I spent a good bit of time on this last time, so I'm not going to go over it again right now. And yeah, I spent some time on this last time. I'm just going to not do that right now. I think I'll look at it off screen. The rest of the stuff I'll look at off screen, and I think, however, it's probably pretty good because I spent a good bit of time on this last time with get name and get string. So that will be it for today. The time has actually run long. And next time, assuming I don't find any huge problems when I look at this off screen, next time we will really be trying to print out tokens and make sure that the scanner works.